Hey coders, I've got something exciting for you today. In the description of this video is a link to 5 challenge problems that you can use to start coding your own solutions to interesting math problems. Watching somebody else code is interesting, probably not as exciting as watching somebody else play video games, but doing your own coding, starting with a blank screen and coming up with your own solution to an interesting math problem is way more fun than watching somebody else do it. Um, it won't be easy the first time that you try this. You'll probably get stuck and not know why something doesn't work, and you'll have to figure out how to run some tests. You might have to pull pieces of your code apart in order to see what's working and how everything's working, but you'll keep at it, and eventually you'll get a solution that works, and it will feel amazing. And not only is this a great feeling, but there's two really cool things that will be happening. You'll be getting better at coding by figuring out how to take problems apart and test things. You'll get better and better at coding. And you'll also get better and better at math. Your understanding of the math concepts will become more solid and strong as you figure out how to code solutions to the math problems. It's like your math skills and your coding skills, they ratchet each other up. Instead of coding a whole solution to a problem today, I'm going to give you a quick tour of Scratch, highlighting the coding blocks that are the most useful and important when coding math problems. And to give us something fun to look at, I've got this program already built. So let's run it and see what it does. I can find the least common multiple of two numbers for you. Scratch the Cat has a program where he says he can find the least common multiple of two numbers. So let's give it a try. If you'll remember, the least common multiple you use when you're looking for a common denominator in division. It's a concept you probably learned in fourth or fifth grade. And when you count by a number, those are the multiples of the number. So if we're looking for the least common multiple of two numbers, that's the smallest multiple that's common to both of those numbers. So for example, the least common multiple of 6 and 8 is 24. So I'm going to put 6 and 8 in here and see if Scratch can give us back the answer. My first number is 6. My second number is 8. The least common multiple is 24. And the cool thing about a program like this is not only can Scratch solve easy ones that I can do in my head, we can also ask him to find the least common multiple for much bigger numbers. So let's try 1,250 and 3,683. So just like that, he found the least common multiple of those bigger numbers. We're going to take a look inside of Scratch and of this program and see what's going on and how it works. And because I'm going to focus more on introducing the different types of blocks, I'm not going to give a full explanation of how this code works. But this project is linked in the description too. And you can create a free account at Scratch. Just go to scratch.mit.edu. And if you click on the link in the description of the video, you can right away open this project. You can click remix, and then it kind of becomes your own that you can do anything you want with it. So you can figure out how the different sections work. And I encourage you to try to understand exactly why this program works. But then when you move on to the challenge problems, you can do it without an example. Try not to look up other people's work when you start doing those challenge problems. Okay, let's take a look inside of this program. Okay, I have collapsed that full view screen, and now over here where Scratch the Cat is standing, this is the stage that shows you what you would see if you run the whole program full screen. And then once we've collapsed it, all of our code is here in this middle block. And all of our code is associated with either a sprite, and that's what we call these little characters, or with a backdrop. And all I have in this program is a white blank backdrop, but you can also attach blocks of code to the backdrop. The next thing I want to show you is the sticky note feature of Scratch. This is Scratch's version of comments. As you're coding, you might want to use comments to share information about your code, either with other users or, as I have in this example, as a plan for what you're going to put into your code as you go along. The way that you create one of these comment sticky notes is by right-clicking. And you can either right-click in the white space and create a sticky note that will be not attached to any part of your code and just free to move it wherever you'd like. And then you, of course, just click in here and type. Or you can also click in a specific area of your block of code, right click there, add a comment, and then it will leave that line connected. So maybe I want to say something about this specific part of my code. So that's how you make comments. The first set of blocks that we'll talk about will be the event blocks. And these are the blocks that you click when you want to start something. They're like the launch or the trigger of all the code that you'll attach below them. This top one here is what begins the program. So when a user clicks this green flag over here, then the whole program starts. And so sometimes we'll just attach all of our code right under that first block that starts the whole program. Other options, I've sometimes attached blocks of code that do a certain part of a math solution to a sprite and then click on different sprites. You could add a new sprite and then add when this sprite is clicked and add some code onto that sprite. You can also do when a key is pressed, so when the space bar is pressed, maybe something will happen. But these are all events that trigger the code that comes below. The next set of blocks that we'll look at that are so important in our math solutions are these variable blocks. And when you create a variable, it will show up right here. Here's how you make a new variable. And when you first make it, it will automatically show up here in your staging area. And when I'm actually working on problems, I'll want to have most of these where I can see them so that I can test and look at my code and see what's going on, maybe run some experiments. But then I'll decide at the end how I want the experience for the user to look or work, and so I might not have these showing up in my final version. So let's leave them up there for now and maybe just rearrange them quickly. Let's delete that one that's not really part of this. And the other variable that's interesting is in this sensing block. When I wanted to get the user to put in the two numbers that we were going to use to find the least common multiple, we used this block too, called the answer block. And at first, at the beginning of the program, we used the look block. And for 3 seconds, he says the words here. But then we immediately went to this ask block where the character that we're coding and that this is all attached to, it's all attached to Scratch the Cat. He'll ask this question and then wait for an answer. And then I want you to watch what happens in this answer variable as we run this program. So let's do 15 and 10. So my first number is 15. So that answer variable right now is 15. And I also added this next after the first ask. I set my variable that I created called first number, and I said set that first number to the answer at this point as we're running the code. And now we've moved on to this block. What is your second number? And he's waiting for my input. And now watch what happens to this answer block when I put something new in here. I put 10 in here and it changed to 10. And so I had to assign that 15 into a variable that I had created so that I didn't lose it. And he went ahead and ran all the rest of our code. So that's variables. The other thing you can find in this same area when you click on the variables over here are these blocks related to lists. And in this problem, we have one list. Let's click in this check in this box so we can see it. And this list isn't very well named. So I'm going to rename it right now. In this solution, the first thing I do is gather up all of the multiples of the first number. So we'll call this multiples of first number. That's a little refactoring, improving our code. So now that it's more clear what this list is. And as I'm looping in this first loop, I'm adding all of the multiples of the first number by multiplying that first number by a counter that in each cycle of the loop is going up by 1. So these are both in the variables. These blocks right here are both in the variables area. The top one is in the lists and this one is in the variables. And as we scroll down through the rest of this code, here's another piece of block of code that came from the list area that's a super useful one. Let me pull it out here. So this is a Boolean. That means just by the shape of it, I know that when the code runs, it's either true or false. So it comes in this if clause in our if block. And so what this is doing is it's checking in the second number's multiples and checking to see if each one of those is already in the list. So if the multiples of first number, so this is the name of the list, if the list contains the second number times the counter, so that's how we're getting the multiples of the second number, and then we go right into the solution. Then we've actually solved the problem. The first time that we find a number that's on our multiples of the first number list that is also a multiple of our second number, since we're doing these in order, then we'll right away have our solution. So that is only to say, though, that there are all of these orange blocks that do things with both our variables and with the list. So if you're thinking about different ways you might want to manipulate numbers, you'll look in all of these orange blocks. And I didn't use all of these in this solution, but I want to show you that you can also refer to a value in this list by its item number, which is this number over here on the side. So if I wanted to say, look at item 4, I would get this block right here and I would put in 4, item 4 of multiples number. And here's a cool thing you can do is just click on the block of code and it'll show you what right now it would resolve to. So item 4 of that list resolves to 60, which is exactly what we would expect. And this is a way to kind of experiment and play with the blocks as you learn them. So that's lists. The next category of blocks that I want to show you are the control blocks. And we will primarily focus on two types of control blocks. The first is the loops. So if you'll notice this little arrow down here at the bottom, there are 3 blocks here that have that kind of arrow, and I'm going to pull them over so we can look at them. And each one of these will continue looping. This first one will loop forever. And let me show you up in here. I used this block, but I included this also control block called the stop block in here that stopped everything when I got my solution. And the thing about least common multiples and the way this solution is designed is it will always hit that stop block, even if the least common multiple is the product of the two numbers. That's true if they're both prime or if they're relatively prime. So we'll always break out of this forever loop, but that's not always true. So you want to be careful with forever loops. So that's one type of loop. This loop is going to repeat a set number of times. And in these kind of math problems, one of the variables that you'll end up putting in here might be the length of the list. I might have had a counter that referenced the index or the item number of these so that we could look at these one at a time. And I would want to do that for as many numbers are in the list, which is another way of saying the length of the list. So this could be a number or the length of the list. This tells us how many times to do the loop exactly. And then this final loop will continue until a condition is met. So there's that Boolean shape. So repeat until whatever I put in here is true, and then don't repeat anymore. So in this solution, we had to do the loop to gather the multiples of the first number when we created that first list, the only list. We looped through here and just kept on adding the first number times 1 and the first number times 2 and the first number times 3. And we had to do that the number of times that is equal to the second number. So like if you think about if I was finding the least common multiple of 5 and 6, I would want my list of the multiples of 5 to end with 30 because 5 times 6 is 30. That is the least common multiple. I wouldn't need to go past 30. So that 30 is the sixth multiple of 5. And then because of how this would stop right when it got there, but I actually need it to do that last loop through and add 30, I have to do this plus 1 here. So this is an example, this looping code right here of repeating this loop until a condition is met. So those are our 3 looping blocks. And the other control block that is so important in coding is this if block. So if some Boolean block is true, then do this. So this one showed up in our second loop when I was looking for a common multiple. So this says if the list has this number, and this is a way of saying the multiples of the second number, then that's the solution. So if this right here is true, do this. And then the other type of if block, sometimes you don't need this second little part of it, but this means if this isn't true, then continue on and do this. And in our solution to the multiple problem right here, if the first time that you run a number in here, so if you're the first multiple of the second number is not contained in the list of the multiples of the first number, then change that counter by 1 and try 2 times the second number. So the second multiple of the second number. Then try 3. So this will keep looping. And it, like I said before, it will always break out with this stop right here because when you hit the product of the two numbers, which will be on the list, then it will stop the script. But yeah, that's how you use an if block. If something is true, then do this. There, are a couple more blocks in here, but those are the main control blocks that you'll need to know about to code math solutions. And the final type of block that you will use in solving math problems are the operator blocks. They're the green blocks over here. And there are two types of operator blocks. The Booleans, which we've talked about, will resolve to true or false. So that's the greater than, less than, equal. And then the and the or block mean that for this one, for the and block to be true, both of these other two Booleans must be true. And for the or block to resolve to true, only one of them must be true. But they both could be true, but at least one of them must be true, and then this would resolve to true. In the operators, we also have our four arithmetic operations: addition, subtraction, multiplication, and division. We have a random number picker that you can choose the range for. This join is to join two strings or words, letters, groups of letters together. The length of a string. And then this mod block is the one that tells you the remainder of a division problem. You can use this one to round. And when I found this block, I felt like I had discovered a whole treasure chest. Watch this. There are all of these operations inside this one block. So oh my goodness, the trigonometry functions, which I know you can say a better different way, some logarithms and exponents. So a bunch more math operators. And that's it. That's all of the blocks that you'll really want to get familiar with to code math solutions. So again, just to review, we started with event blocks to get the code going, something that initializes. Often it's the green flag. We talked about the variables, and under the variables section, it also has lists, a button to make a list, and then some blocks that you can use to get at and manipulate lists. Then there's also the control blocks, the loops, and the conditional if statements. And finally, we just looked at the operators. So those are the blocks in Scratch that will help you code solutions to math problems. Okay, that's it. Those are the coding blocks in Scratch that will be helpful, important, useful to solve math problems. I'm really excited for you guys to get those problems that are linked in the video description and start coding your own solutions. You can share those with me directly in Scratch. You can paste links into the comments here. My username in Scratch is CookieBrains555. And my next episode is going to be both a Scratch and a Python solution to the third Project Euler problem. If you want to give that one a try as well, it's a good one. I'll see you soon, and don't forget to like and subscribe.